My name is Aaron William Guest, ID number 24847. I'm from Civil Engineering. So today I'll explain how to solve two questions. So here's the first question. So basically is they asking use the force method to determine the reactions at the supports for the beam, and later on you have to draw the shear force and bending moment diagrams. Alright, and here B, the support at B is a roller and EI is constant. So right here is the principle of superposition. This is the principle of superposition. Basically it's R equals 3n, and the n is 1 because it involves only one beam, and the reaction, the R is actually unknown reactions, and it's 4 because as I said, B at B is a roller, so there's only By force, and A is a fixed support, so there's moment Ax and Ay. Alright, so basically you get this 4 more than 3, so it's indeterminate and it's the first degree. Alright, so next we move on to the compatibility equation. So this is the primary structure, and we include the UDL in the primary structure, and we take out the support that which we think that's a redundant force. Alright, so we take out the redundant and we put delta B, and the second one is we apply the redundant, which is By. We chose By, and basically here is By, and on top here is By FBB. So we move on to this equation. So compatibility equation is basically negative delta B plus By FBB equals 0, and the delta B you can get from the table that is given, and the FBB also you can get from the table. And when you compare them side by side, delta B equals By FBB, you basically substitute the formulas, and here the P becomes By. P is By, so it basically comes this one. And after you calculating and support and replacing the values, basically here you will get 3WL over 8 for By. And as for here, we want to, because the question asks, we have to get all the supports. So next step is we find for AY, right? So we take Fy equals 0, and then we put all the forces in the y-axis, and once we put all equals 0, right, say Ay minus WL plus 3 over 8 WL equals 0, we will get Ay equals to 5 over 8 WL. And next we will find for the moment. So the moment is equals to 0, we take it as, and once we put all the moment together, it becomes negative m minus WL square over 2 plus 3 over 8 WL square equals 0. And after doing some calculation minusing, you will get MA equals negative 1 over 8 WL square. Alright, as for the next step, so remember this is the diagram, and so I cut it into half, and basically you'll get this. Alright, so the first step is if you want to find Fy and M, so basically you use all this Fy forces and you'll get this. Alright, so V equals negative Wx plus 5 over 8 WL. Alright, and as for the M, the moment is here. So you take all of this and you put inside the moment equation, and you get the M equals M equals negative 1 over 8 WL square plus 5 over 8 WLX minus W over 2 X square. Alright, so the question asks you have to do these two, shear force diagram and bending moment diagram. Alright, so the first step is you have to find the V, alright, the maximum V. So the maximum V you can get by using this formula. So when x equals to 0, you will get 5 over 8 WL. So you'll get 5 over 8 WL, right? So if you substitute x with 0, basically negative W times 0, you'll get this, right? Alright. So that explains how you get this. And then when you substitute x with L, alright, you will get negative 3 over 8 WL. So that's how I get this shape in my shear force diagram. As for the bending moment diagram, first off, you repeat the process, as in here you substitute x equals 0 and you will get for here this value. Alright, so when you replace x with 0, you will get this equation. You will get this m equals negative WL square over 8. That's this value here, right here. And as for here, you replace x with L. So once you replace x with L, eventually you will get this m equals 0. That's why it stops here. However, we need to find the max moment. So to find the max moment, we use v equals 0. Alright? When v equals 0, okay, we substitute here. Alright? And then you will get 5 over 8L. So for this 5 over 8L, you take it and you put inside this equation for the x. So this x equals 5 over 8L is where the maximum moment happens. So we take it and put inside this equation, and once you do it, here is it. So I have substitute 5 over 8L inside the equation, and eventually I'll get 9 over 128 WL square, and that's right here. Alright, so moving on to question number 2. Alright, so this is question number 2, and they say use the force method to determine the directions at the supports for the frame shown. So this is the diagram. Alright, okay, so this is the principle of superposition, which is R equals 3n, and from the diagram I can get 10 unknown reactions equals to 3 times 3. 3 is basically the number of parts that involves in this thing. So here's the first one, second one, and third one. That's why we put 3, right? So it is indeterminate to the first degree. Alright, so next step is the compatibility equation, which is 0 equals delta C plus Cy FCC. So right here we took out our choice of redundant force, which is Cx. We replace it with delta C. Alright, so, and this is primary structure, and for the second one we put Cx FCC, and this is the virtual, basically it's the virtual load, and this is the actual load. So the virtual load we replace with Cx FCC. Alright, so the next step, for the actual load, we use the summation of moment. Alright, so after you sum it all up, you will get Cy equals to 202.5 kilonewton, and for the same thing for summation of Fy, so all of the y forces, we sum it up, and in the end we'll get Ay equals to 157.5 kilonewton, and for Fx we get Ax equals 90 kilonewton.
Yeah.
Okay, so right here we got the Ay, the Ax, and the Cy. Alright, so we use all of those values and we put it to find summation of m for m1. So after you sum everything up, you will get m1 equals to 157.5x minus 30x square. And as for m2 is the same thing, you will get m2 equals negative 15x square. Alright, so the next step is you want to find the support reaction for virtual load. Alright, so it's basically the same thing as before, but only involves virtual load. So you replace Cx with 1, and for the summation of moment, you will get Cy equals to 1 and 102. Alright, so for Fy you sum it all up, and you will get Ay equals negative 102. And as for Fx, after you do the summation, you will get Ax equals to 1. Alright, so for the next one, it's basically the same thing as the top for M1 and M2, which is it involves the virtual load So for M1, after you do the summation, you will get for M1 is negative 0.5x, and for M2 you will get negative x. Alright, for the next step, we're going to find delta C and FCC. So delta C is basically for the actual load, the values involving actual load, and FCC is values involving the virtual load. So by using M1 and M2 from the actual load, we replace all the values in here, and in the end we'll get negative 506.25 over EI. Alright, and as for FCC, we use the M1 M2 from the virtual load, and we substitute inside everything, and we'll get 27 over EI. And by using the equation, we substitute into delta C plus Cx FCC equals 0 to get Cx. So once you substitute everything, as you can see here, we will get Cx equals 18.75. Alright, so we have the Cx now, and now we're going to substitute into these new equations to find the support reactions. So once we put the Cx, which is 18.75, we use the summation of moment, and we will get Cy equals 211.875 kilonewton. And the same thing is using the summation of Fy, we will get Ay 148.125 kilonewton. And we do the same thing for the summation of Fx, and we will get Ax equals 108.75 kilonewton. And that is all for the two questions. I solved it, and yeah, thank you.